You will understand what is IoT, how is IoT working, what are all the terminologies and definitions that are connected to IoT, what are the prospects of IoT, and most importantly, you will also understand what not is IoT. Finally, we will touch about the difference between cyber physical system and IoT. IEEE is the body which is actually governing the entire science and technology, and they have a definition for IoT as well. The Institute of Electrical and Electronic Engineers define IoT as a network of items, each embedded with sensors which are connected to internet. It's a very simple, straightforward definition. I need to have many items which are all having sensors, they are all networked, and they are to be connected to internet. That is it. And this is what we are going to learn in this entire courseware. We will know how to network items, we will know how to connect sensors, we will know how to use internet for acquiring data and to do the control action, and that's overall called as IoT. IoT's definition can be further taken forward with little more addition to the definition that has been given by IEEE. The IoT is the network of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange data. The same definition which has been given by IEEE has been modified a bit here and there to make it better. Here you can see that the items can be physical devices, vehicles, buildings, you, me, and anything. And all of them must have the support of electronics, software, sensors, and network connectivity, without which we cannot get all these complete. And now it's time to understand, is there any other definition which is a bit closer to this definition of IoT, which is already in existence? Yes, interestingly, ETSI, which is European Telecommunication Standards, has defined something which is pretty much close to IoT's definition, and they named it as machine-to-machine intelligence. They say that machine-to-machine intelligence can be defined as the communication between entities which do not require manual or human intervention. This automation enables machines to take decisions on its own without manual intervention. This is called machine-to-machine intelligence, and we feel that this definition is pretty much closer to the one of IoT. Well, do we have any standards for IoT? Yes, IEEE has done that as well. IEEE has identified about 140 existing standards and projects which can be connected closely to the IoT. And where do we get all this information from? We can get all this information from standards.ieee.org/innovate/IoT. This website has got a lot of information, and I urge each and everyone who wishes to learn IoT to visit this site first to get more fundamental knowledge, then to build your further areas stronger in and around that. Some of the prominent projects of IEEE which are in the sector of IoT are vision-based automated parking using IoT, earthquake and tsunami simulation through GSM network, intelligent traffic light controller using GSM, design and implementation of PAR sensor-based security system, and many more. This is just a glimpse and maybe not even a percentage of what they have presented there. It is much more, and we will get a lot more information as well when you start surfing. There are so many standards, you can verify all of them in the link that has been presented to you right now. There is a question which is often raised when you say that you know a bit of IoT. What is the difference between cyber physical system and IoT? Are they the same? No, they are not the same. There is a lot of confusion running around. There are a lot of jargons connected to it. We are going to classify them clearly right now. This difference is very important for you to take your learning to the next level. CPS, which is cyber physical system, is more fundamentally complex. Yes, it is definitely very complex. In CPS, mechanical, electrical, electronic systems come together and are networked. Software plays a very major role in the networking and interconnection of all these components. CPS systems can well be independent in the decision making, although with appropriate control, and it is certainly not just identification of a thing in network. CPS is much more brilliant and has much more authority. One thing has to be clarified here. Is IoT not CPS then? No. IoT is fundamentally less complex. You can take an aeroplane as an example right now. You've got wings, and the wings have got so many sensors. You've got other areas of aeroplane including the cockpit, including tire areas, and so many sensors are there. And all those sensors acquire data real time and they send it to a central processing unit. And the decisions are taken during real time analysis. That can be qualified as CPS because it involves mechanical, electrical, electronics, and all of them are driven through the software. It is complex and it is perfectly real time because the decision cannot be delayed. In better words, CPS has got smaller amount of IoT inside it, but IoT has got no CPS. IoT is lesser complex, CPS is much more complex. CPS is mainly concerned with collaborative activity of sensors or actuators to achieve a certain goal. To do this, CPS uses an IoT system to achieve the collaborative work of the distributed system. Hence, you need to understand this way. IoT is one of the components, or IoT is one of the smallest players of building a complex CPS system. CPS can be employed in many areas which include smart grid, autonomous automobile systems, medical monitoring, process control systems, etc. This is going to be the future, and for you to become a CPS expert, you need to certainly become IoT expert. And this courseware will help you to do that. The next question obviously would be, is IoT the same as wireless sensor networks? Wireless sensor network is a network which is built with multiple autonomous sensors. These sensors could be pressure, moisture, temperature, humidity, or sound, and any other type. All the sensed data from these sensors shall be transferred to centrally located server. The data transfer shall be taking place in a coordinated pattern. WSN is composed of nodes which can range from 1 to thousands, with each node having one or more sensors. So, one can conclude that WSN is all about coordinated data collection and nothing more. The scope of IoT is much bigger. IoT is not just about data collection, and it has got some more intelligence embedded to it. It can take decisions, it can drive a system further, and yes, it is complex than WSN. WSN can be quickly defined as coordinated data collection from multiple sensor nodes in the same time. IoT we have already defined. Thank you, and the next session will give you much more information about IoT.